Analyze the chemical composition and structure of the compound. Sodium glycinate is a salt formed by a sodium cation, not to the power plus, and a glycinate anion, H2NCH2SO to the power negative. Identify the primary bonding type, properties of solids because the substance is composed of a metal cation and a polyatomic organic anion. The primary attractive force holding the particles together in the crystalline lattice is ionic bonding, strong Coulombic attraction between oppositely charged ions. Relate bonding type to physical state at room temperature. Substances held together by strong, three-dimensional networks of ionic bonds have high melting and boiling points because a massive amount of thermal energy is required to disrupt the electrostatic lattice. Therefore, sodium glycinate is a stable, crystalline ionic solid at room temperature, which identifies option A as the correct statement. Evaluate water solubility. Due to the presence of the sodium cation, not to the power plus, sodium glycinate behaves like other sodium salts. The strong ion dipole attractions between polar water molecules and the ions easily overcome the salt's lattice energy, making it highly soluble in water. Evaluate volatility and evaporation. Because ionic bonds are extremely strong, ionic compounds have negligibly low vapor pressures and do not evaporate easily. Evaluate the acid-base behavior of the dissolved salt. The glycinate anion is formed through the loss of an H to the power plus proton from the carboxylic acid group of glycine. In water, this negative carboxylate group behaves as a weak base, accepting a proton from water to produce hydroxide, OH to the power negative, ions. Because the glycinate ion is a proton acceptor and will not readily lose another proton, it dissolves in water to form a basic solution, not an acidic one. The correct answer is option A. It is an ionic solid at room temperature.